Guys, today I have some pretty interesting news for you. Not so long ago, people used to create robots, right? But now, thanks to a new project by Peter Burke, that is all in the past. Peter Burke's project uses generative AI to autonomously develop drone software, transforming robotics. The system uses AI models like ChatGPT to generate code, reportedly enabling robots to operate independently. With 10,000 lines of code in 100 hours, the AI-driven process is 20 times faster than old methods. Experts are shocked at the innovation, but do call for the need for safety measures. So, now let's dive right into the details. A project straight out of a movie. In a project that feels ripped straight from the Terminator franchise, computer scientist Peter Burke of the University of California has created a system where an AI-powered robot designs the brain of another robot 20 times faster than human engineers. Using generative AI models like ChatGPT, Claude, and Gemini, this breakthrough could change robotics and autonomy. But with such power comes a dangerous question. Are we moving closer to a world where machines can build themselves? How the project works. Burke's research describes two types of robots. 1. The AI model. Generative AI tools, ChatGPT, Claude, Gemini, running on cloud-based. Servers responsible for writing the drone's code. 2. The drone, a physical flying robot equipped with a Raspberry Pi 02W, which runs the AI-generated software. Instead of relying on standard control software like Mission Planner or QGI Round Control, Burke's system, called WebGCS, uses AI to write its own autonomous flight control program. The system consists of lower brain, handles flight mechanics through drone firmware. Intermediate brain, GCS, manages mission planning, maps, and settings. Higher brain provides real-time obstacle avoidance and partial autonomy. Unlike traditional systems, WebGCS can be hosted directly on the drone itself, making it accessible via an onboard web interface built with Flask. AI development sprints, building a brain. Burke's team employed a series of coding sprints, using different AI models and development tools to progressively build the system.
Tired of your coffee going cold? The Ember mug keeps your drink perfectly hot, so the last sip is as good as the first. The perfect upgrade for you, or a great gift for our loved ones. Click the link in the comments section to buy now.
Sprint 1. Claude. Initial attempts failed due to context window limitations, as the AI could not retain large amounts of information. Sprint 2. Gemini 2.5 showed promise but ran into similar issues with handling complex code architecture. Sprint 3. Cursor produced a prototype but required extensive refactoring into smaller modules. Sprint 4. Windsurf finally delivered a fully functional version of WebGCS 10,000 lines of code generated in only 100 hours over 2.5 weeks. Oh, and this isn't for the weak. Burke's previous drone project, Cloud Station, took 4 years to develop. This represents a 20 times speed improvement, a huge leap in efficiency, a glimpse into the future. As someone who has followed AI and robotics closely, this project feels like a huge deal, and I honestly don't understand why people aren't talking about this more. While Hollywood loves to warn us about robot uprisings and robot taking over, Burke's work shows how generative AI can help us. Imagine a future where autonomous robots can design their own upgrades in days, I guess we can say. Goodbye to our jobs. AI can maintain and repair entire fleets of machines without human coding. And there goes my dream of being a robot handler. Complex robotics projects become accessible to small research teams and startups. However, this also raises huge safety concerns. What happens if such systems evolve beyond our ability to control? And now is the time to create more movies about robot uprisings. Could a wrong prompt lead to dangerous autonomous behavior? This is why we keep repeating the Terminator reference. For those of you who don't get it, what experts are saying. Industry professionals are somehow optimistic. Hans Fevry, CEO of spatial data company Geolava, told The Register, "The idea of a drone system autonomously scaffolding its own command and control center via generative AI is not only ambitious, but also highly aligned with the direction in which frontier spatial intelligence is heading. However, I strongly believe there should be hard checks and boundaries for safety." This seems to reflect a growing opinion. AI-powered robotics is here to stay, but its development must be carefully monitored. Yes, finally, I can have this monitoring job in the future. Why this is important for AI and robotics. Burke's work highlights several points in AI-driven engineering. Rapid work. AI can compress years of development into weeks. Ease of access of robotics. Small teams can now build complex systems without massive funding. Move toward autonomy. AI systems are no longer just assisting, they're taking over. Core design tasks. These could have profound effects for industries like aerospace, defense, logistics, and manufacturing, where autonomous systems are becoming essential.
What if your water bottle glowed to help you reach your hydration goals? The Lark bottle does. Its smart sensor tracks your intake and glows to remind you when it's time to drink. Plus, it purifies your water on the go. Prioritize your health with the perfect gift for you and your loved ones. Click the link in the comment section to never forget to hydrate again.
Public reaction, fascination, and fear. Online discussions about Burke's project have been strange. Here are some opinions on social media and forums. Tech enthusiasts. This is a game changer. Imagine what startups can do with this. Tech. Cautionary voices. Impressive, but remember, Skynet started like this. Researchers. It's exciting, but AI monitoring must advance at the same pace as innovation. The mix of awe and apprehension reflects society's weird feelings toward AI. There is a hope for progress, but also a fear of losing control. New breakthrough developments makes robots even more smarter. Peter Burke's drone project, where generative AI built the brain of a drone in just 2.5 weeks instead of 4 years, is a sign of big changes ahead. Around the world, new tools are emerging to make robots think faster, act smarter, and learn with less human help. 1. Jetson AGX Thor, a super brain for robots. Nvidia just launched the Jetson AGX Thor, a powerful onboard computing module that acts like a brain for robots. Priced at about $3,499, this robot brain gives machines enough power to run advanced AI models directly on board. No cloud needed at all. Key details. Comes with a Blackwell GPU and 128 gigabytes memory, delivering up to 7.5 times more AI computing power than the previous Jetson Orin model. Used by top robotics teams like Amazon Robotics, Boston Dynamics, Meta, and others. Why it matters. Just like Burke's drone hosted its own control system, more robots can now think and act in real time, all from onboard hardware. No more delays or cloud dependence. 2. FieldAI raises $405 million to build one brain for all robots. Meet FieldAI, a startup recently backed with $405 million in funding to create a universal brain for robots. Here's what they're doing. Building field foundation models, AI systems that help robots understand and adapt to the physical world using an awareness of physics. With these models, a robot could learn one skill, like opening a door, and apply it in many different settings without needing to be reprogrammed. Why it matters. Imagine powering all types of robots, drones, humanoids, delivery bots with one adaptable brain. That's what FieldAI is aiming for. Reuse, readjust, restart. Bottom line. Peter Burke's Drone Brain project showed us what's possible when AI writes AI quickly and creatively. So, what do you think? Let me know in the comments below, and don't forget to subscribe for more info on AI robots and new technology.